Today we looked at standard deviation. This is Friday, September 3rd, and you can see that we were still using our travel time data for, this was for, I believe, 7th period. So let me scroll to the standard deviation page. Here it is again, the travel time data. We've talked about the mean, we've talked about the median. We talked about how those affect the mean, how shape affects the mean and the median. Then we talked about box plots yesterday. And we are going, whoops, let's get rid of all that and start from scratch. So here is standard deviation. Up top, that's the formula for variance. And then at the second one is the formula for standard deviation. So I believe the second one is the one that's on your formula chart. You might copy down that definition at the top, especially this phrase right here is crucial to interpreting the standard deviation. So here's some symbols and notation. When you see S squared, that's talking about the sample variance. When you see S, that is talking about the sample standard deviation, which is what we use in AP stats. If you're an IB doing stats, you guys will use, oh, that's an ugly sigma. Let me try again. A little better. I'm going to try one more time. I don't know. So that's a lowercase sigma, and that refers to the population standard deviation. We talk about it in this class, but we don't actually use it because all of our stuff in AP statistics is sample-based. Whereas in IB, you work with a lot of populations, so you use sigma. So in this class, we're going to use that right there. Or on the output, it'll be SX. So I'll show you in just a moment. Sigma squared is the population variance. In here, we talk a tiny bit about variance, but not much. Most of our stuff is standard deviation. If you go on and study stats later in life, the next one up, you'll work with variance quite a bit. So this number right here, the numerator, that's the sum of the squared deviations from the mean. Let's write that out. And this is a form of an average. I'm going to erase all our symbols here. So we have a little bit more room to work. So this calculation is a form of an average. And whoever was thinking this up first, they started with a deviation. You take one value, subtract the mean, and that right there is a deviation. But why square them? If I add up all those deviations, that's an ugly summation. A little better there. If I add up all those summations, maybe pause the video, think about it for a minute. What do we get? You should be able to figure it out, no matter the data set. Some of those deviations are going to be negative, some are positive. They all hover around the mean. So when I add them all up, I get 0, which does us no good. So whoever thought this up, they said, well, let's square them. Let's get all positive numbers. Let's add them up, and we have that. So this right here is our variance, sample variance. This one is on your formula chart. That's our sample standard deviation. Say that as many times as I can. In AP stats, we use S. On your 1var stats output, it says SX. There are some characteristics there at the bottom that are kind of interesting. So you might copy those down. We're not going to do the home run king problem. We'll do standard deviation for our data set. Standard deviation can't be negative. It'll always be greater than 0. I guess it could be 0, but that'd be very boring. There'd be no variability. Everyone's number would be the same. Units are the same as whatever you measured it in. So ours will be minutes for this problem. It is not resistant to outliers. Outliers have a big effect on standard deviation. So let's do it on the calculator. Get out a full screen. Here's our calculator. Hopefully you've typed in all the data. If you haven't, rewind the video, pull up the data set, type it all in. I named mine A. Let's run one var stats. Menu, stats, stat calc, one var stats. I have one list. I named mine A, and then click OK. And there's our sample standard deviation right there. If you go down one below it, we don't want that number. That number was divided by n. This number is divided by n minus 1. If you look at the formula, see it's divided by n minus 1. They do that to eliminate bias. It helps this estimate right here, the standard deviation. It helps it estimate the population better when you divide by n minus 1. Remember, we're working with a sample. We're not working with the population. So if we're working with the sample, it tends to do a better job of estimating standard deviation when you divide by n minus 1. So back to this, we're going to copy this down, 7/1966, and interpret it. So S is 7.1966, and we could say something along the lines of AP Statistics students in 7th period times to travel to school are on average or typically 7.1966 minutes from the mean. Said that a little better than I did in class today. A whole other way you could do it, if you don't like that, are on average, so this is an or right here, on average within, pull up my calculator, 7.2478 and 21.641 minutes. Where'd those numbers come from? I did X bar plus or minus S, so that was 14.4 repeating plus or minus 7.1966. That's where that interval came from. So I typically stick with this right here because we don't really need to pick up our calculator more than we already have. But some people like to have a concrete range that they're referring to. They feel like that's too vague to say it like I did. So they like to give it an interval. But there you go. Hope that made sense. See you in class.